All right, so here's a key for solving these energy problems. Okay, so you're going to have three equations to pick from. Okay, the first page, number 1 through 3, we're going to be using the kinetic energy equation. All right, so you can see that kinetic energy, right, is based on kinetic energy is 1/2 the mass times the velocity squared. Okay, so that's the base equation that you're going to use. Okay. All right, so a hockey puck of mass 0.2 kilograms, so that's the mass, is traveling at 20 meters per second. That's the velocity, okay? And in this problem, we're solving for the kinetic energy, okay? So that's the unknown, so you're going to write that with a question mark. And then you need to list out all the other things that you know. So I know that the mass, 0.2 kilograms, the velocity is 20 meters per second, okay? And then you need to write the equation, isolate, and solve, all right? So you really want to practice always writing the equation first before you put numbers, all right? And then you need to isolate the variable. This is just good practice, and this is going to help keep you from making mistakes, all right? This one, we're solving for EK, so it's already done, okay? So now we are ready to plug in the numbers. So 1/2, okay, the mass is 0.2 kilograms, okay? And the velocity is 20 meters per second. That whole thing is squared. All right, now you can just plug this into your calculator if you want, okay? But for this purpose, I'm just gonna write a few more details, but you could just put the answer here, okay? So 1/2 of 0.2 is 0.1 kilograms, okay? And then 20 meters per second squared is gonna be 400 meters squared per second squared, okay? And again, you can skip this step. You don't really have to do that, okay? So then if I multiply that together, okay, I'm going to have 0.1 times 400 is going to be 40, okay, and the units are kilogram meter squared per second squared, all right, and a kilogram meter per second squared is a Newton, okay, so this unit here is really a Newton meter, which is a joule. And that's the energy unit, okay? And you could just put 40 joules, right? So like this line and this line, these you don't really have to write, okay? But you do need to write the equation, isolate, which is already is, plug in the numbers and solve for the answer and put the units, okay? And the energy unit's always gonna be joules, all right? But I was just showing you some extra steps. Okay, all right, so that's the easiest way because you don't have to isolate anything. Now, let's go to the second one. You throw a 0.5052 kilogram ball, so that's a mass because it's in kilograms, okay? And it gains 6 joules of kinetic energy. What is the velocity? Okay, so the velocity is now the unknown thing. I know the mass is 0.052 kilograms, and the EK is 6 joules. All right, so since I know this is a kinetic problem, I'm going to go ahead and use the kinetic energy equation, so 1/2 mv squared, all right? And then this is the trickiest one because I'm solving for v, all right? And v is right here, all right? So that means I need to move everything else away to the other side, all right? And the easiest thing that I would do is I would multiply both sides by 2, right? Because then that's going to get rid of the 1/2, okay? And again, you don't have to show quite so many steps, but you do need to isolate it. mv squared, all right? So now I'm going to have the v squared is what I want, okay? So now the mass is the bothersome thing. So I need to divide both sides by mass. So then I end up with v squared equals 2ek over m, okay? And I don't want it to be squared. I want it to just be regular. So in order to like undo the square, I have to take the square root of both sides. So then I end up with an equation that looks like this, 2 times EK over the mass, take the square root of that whole thing, and that's the velocity, okay? So again, you don't need to show as many isolation steps, okay? Some of these, depending on your math ability, you might be able to kind of do in your head, or some of you might need to do each step, which is fine because that's really, really good practice for your algebra, okay? All right, so then we'll go here, and then let's go ahead and now we can plug in the numbers. So 2 times 6 joules divided by 0.052 kilograms. Okay, so I'm going to have 2 times 6 is 12 divided by 0.052. So then I'm going to get 230.8. Okay, and then my units are joules per kilogram, which is sort of weird. Okay, and then I need to take the square root of that, and then I'm going to get 15.2, okay? And don't worry so much about being able to manipulate from joules to kilogram here, but you know that velocity should be in meters per second, okay? So then that should be your answer, all right? 15.2, okay. Number 3, let's see, this is still the kinetic energy page. So a ball is rolling at a speed of 5 meters per second, that's your velocity, 98 joules of EK. Okay, now we're looking for what is the mass. Okay, so now my mass is the unknown. I know V is 5, and I know EK is 98. All right, so I'm going to start again with my equation. All right, write the equation first. That's always step 1. Now this is slightly easier because now I'm solving for mass. Okay, so I just need to get rid of the other stuff. So I'll multiply by 2 to cancel that out and get a 2 over here. So then I'm going to have 2EK equals mv squared. All right, and then I want the mass, so I'm going to divide by v squared on both sides, and then that's going to get rid of that, and then I'm going to end up with an equation that looks like this, over v squared. Okay, right, you might be able to do that all in one step in your head, which is fine. Okay, but either way, I do want to see the variable isolated before you put any numbers. All right. Okay, so then the mass is going to be 2 times the EK, which was 98 joules. Okay, and that's divided by 5 meters per second. That whole thing is squared. Okay, so again, don't worry so much because the units are slightly confusing. 2 times 98, okay, and then divided by 5 squared, or 25, is going to give me 7.84, and since it's a mass, I know it's going to be in kilograms. Okay, you definitely need a calculator, and if some of these calculator steps are difficult for you, you need to ask for help so you know how to use the calculator properly. Okay, don't use Siri, don't use your phone, don't use Google, whatever. Get an actual calculator and use it. All right, okay, so that's the first part. Done.